In this video, we'll be solving this differential equation given the initial condition that P of 0 is equal to 3.9. So first, I don't like these decimals, so I'm going to convert them into simplified fractions. And so this is looking much better for me to work with. And notice that this is a separable differential equation, so I can divide this entire right side to both sides and then multiply both sides by dt. Now this is looking pretty messy here, so I'm going to factor out by the largest denominator of the two. So in this case it's 100,000. And I'm also going to factor out the negative because I want this p squared to be positive. So factor out a negative 1 over 100,000. And notice that it's 17p squared minus 3,180p inside. And so 1 over negative 1 over 100,000 is just negative 100,000. And yeah, this looks a lot better, so it's more manageable. Now at this point, we can do a couple things. We can either complete the square by factoring out a 17, but truthfully that's going to be quite a bit of work, so why don't we factor out a p squared instead. So whatever's inside the parentheses now is 17 minus 3180 over p, and so we're going to let u equal whatever's inside the parentheses. So the derivative of that will be 3180 over p squared dp. Now I do have dp over p squared already, so I need to divide both sides by 3,180 to get dp over p squared. And I'm just going to factor that out. So both the negative 100,000 and the 3180 get factored out. I'm left with 1 over u du. And then I'm going to apply the integral to both sides of the equation. So on the right we just had dt, but really dt is the same thing as 1 times dt. It's the same thing. Now integrating 1 over u is very simple. It's ln of u. And I also simplified this fraction to negative 5,000 over 159. The antiderivative of 1 is just t, and then just add the constant there. U we said it was 17 minus 3180 over p. And so now I'm going to multiply both sides by negative 159 over 5,000. I'm going to also multiply the constant by that, but I just get another constant, so I'm just going to leave it as c. My goal is to solve for p, so first I have to undo the natural log, so I'm going to raise both sides by e, like this, and then the e and the natural log will cancel, so I have 17 minus 3180 over p. Now I'm going to subtract e to negative 159 over 5,000t plus c, and then add the 3180 over p to the right side. I want to solve for p, remember, so I'm going to flip both sides. And here, I separated this, so really this is e to negative 159t, or negative 159 over 5,000t times e to the c. And then e to the c is another constant, and just to vary it, I just let a be that constant. So I don't really care what letter use here. You can still use c if you want. And so I flip both sides, and now I can solve for p by multiplying both sides by 3180. Now the only issue is I don't know what a is, so I have to use the initial condition that p of 0 is 3.9. So now we have 3.9 is equal to 3180 over 17 minus a, because if I plug in t equals 0, this is basically e to the 0, which is 1. Okay. Now, I skipped some steps here, and I said that a is negative 10,379 over 13. So now I can add a back into the equation, and so I have my equation for p. But if you don't like this 13 in the denominator, you can multiply the top and the bottom by 13. And end up with this equation. Another thing you could do also is multiply top and bottom by e to the 159 over 5000 t. But it's just extra work, and I didn't feel like doing that. Okay, now let's answer a question. So this formula represented the population of the United States since 1790, but the actual population in 1900 was 76 million, and T from the formula represented the years since 1790. So what we're going to do is plug in 110 for T, because 1900 minus 1710, oh sorry, 1790 is 110. So T is 110. Plug it into the formula and get 77.264 million. So obviously that is an overestimate of the actual population. So we want to find the percent error. So we're going to take our predicted value, our 77.264, subtract it from the actual, and then divide it by 76. And so multiply by 100%. So this is 1.663% is the percent error.